we are learning about this job scheduler. So this has got a two algorithm here, which is nothing but a FIFO and shortage job first. So out of that, we are going to consider FIFO. FIFO stands for first in, first out. So this particular algorithm refers to a queue principle, where whatever the process that is being coming into a queue at the first place has to be served at the first. Okay, so in this particular context, we have a process sequence something like this. Process ID we have got 1, 2, 3 as a process ID. Process 1 arrived at 10.00, that is the arrival time. Then process 1 takes 2 hours of execution, that is runtime. Then process ID 2, it arrived at 10.10 and it will take 1 hour. So in case of process ID 3, it arrived at 10.25 and requires 0.25 hours of execution. Okay, so if you look at this representation, how this is being looking at the memory, how this will be looking at the queue side. So this is in queue, you have got a P1, so which is arrived at 10.00, requires 2 hours of time. P2 arrived at 10.10, requires 1 hour of time. P3 arrived at 10.25, requires 0.25 hours of time. So if you look at this particular, this is nothing but the time factor which you are going to have. Okay, so in order to calculate some of the attributes and calculate the performance of the system, we need to aware with some of the formulae. Okay, so what is that first parameter that we are going to have is nothing but the turnaround time. Now turnaround time is being referred with the capital T, and turnaround time is computed as T is equals to, so if we can say it is Ti is equals to Fi minus Ei. Fi stands for the finish time and Ei stands for arrival time. So where I is nothing but the process ID. Say for example, if we need to compute turnaround time of process number 1, so we say T1 is equals to F1 minus A1. So it is arrival time of the first process and this finish time of the first process. Okay, so this is going to be like this. Okay, so I is the process ID, Fi is the finish time, Ei is the arrival time. If you look at the average turnaround time, if we have 3 processes in pipeline, so average turnaround time taken by a processor to process these 3 processes uh, will be will be referred as sum of all turnaround time divided by n number of processes. So which means that ATA, that is average turnaround time, is equals to sum of all turnaround time multiplied by 1 upon n, which is being written as sum of all TIs, where I goes from 1 to n divided by n. N is nothing but the total number of process participating in a queue. N is nothing but total number of participating process in a queue. Right now here n is equals to 3. Okay, so we will compute the job scheduling under non-multi programming environment for first in first out algorithm. So we have got an arrival time. AT stands for arrival time. Then we have got okay, we have to work with the start time. Okay, while discussion, I'll let you know like how these parameters are significant. Okay, then you have got a finish time. You have a finish time, and afterwards, post that, you have got a turnaround time. Okay, now let us try to just put a formula also here. So formula of what's formula for the some important parameters. So say this finish time is what? Finish time is FT. FT is nothing but ST plus RT. RT stands for run time. So finish time is nothing but start time minus this. Okay, start time is nothing but ST. Now turnaround time is nothing but what you need to compute is finish time minus TI, that is turnaround time, is nothing but FI minus finish time minus arrival time. Okay, so these are nothing but the formulas that we are going to have. Okay, so let us see that you have got a process ID 01, so that is process ID 1, which is arrived at 10.00. The start time now look at this at 10.00 we don't have any process. So like, and this is under non-multi programming, non-time sharing environment. So here the kind of consideration you need to give understand is there is one-to-one correspondence between one process, one processor. So at 10.00 you don't have any process, so the start time for 10 point process number 1 will be 10.00 only, and it will finish it by 12, because it will take 2 hours of time, so it is say 12.00. Okay, so the turnaround time which is being taken by this particular process will be 2.00, right? Because start time is 10.00, runtime required, this is going to be a runtime, so this is called as RT. So runtime is 2 hours. So start time plus runtime is nothing but 12.00. So you can easily compute. You can easily compute the finish time. Okay, you can easily compute the finish time. Then you can go for second 10.10. So now 10.10, which is arrived at 10.10, but it is being served, because once this particular process is over, then it is being served. It is 10.12.00. It is executed for 1 hour of time, so it will end up with 13.00. So here 13.00 minus arrival is 10.10, it is nothing but 1.2.90 hours. Okay, so we are taking it at a roundup of 100, so don't get confused with 60 minute and all that. Okay, so this is 30 third process, it is arrived at 10.25, but it is being started at 13.00. It will require 0.25 hours, so it is nothing but 13.25 time. So this is going to be the finish time will be 3.00. So now what you need to do is, once you have got this, you need to compute the turnaround time. So the turnaround time for this will be say 0.009. Then this is 2 to 4 plus 3, 7.90. So the turnaround time is 7.90 here. So total turnaround time. So total turnaround time is nothing but, that is, you can say sigma I is equals to 1, 3 till I equals to 3. So it is turnaround time, sum of Ti. So this is total turnaround time. So total turnaround time is nothing but, you can say 2.00 plus 2.90 plus 3.00, which is nothing but 7.90. Okay, so average turnaround time is nothing but total turnaround time, TAT divided by N. So N is 3, so TAT is nothing but 7.90 divided by 3. So the average turnaround time taken for all these three processes using a FIFO algorithm will be 2.63 hours. Okay, so this is what actually the concept is. So this is nothing but FIFO scheduling with respective to non-multi-programmed environment.